This is a video to explain how to use that tool known as the protractor. So for many of you, it's been a while since you've had to use the protractor. Maybe you used it in geometry, maybe you used it in other science classes, but this is a little refresher for how to use it. First thing that we need to recognize that the convention that we're going to use for this particular course is that to the right-hand side, or east on a compass, is going to be what we define as 0 degrees, or also 360 degrees, and we are going to go counterclockwise in rotation. So if you look at the inner numbers there, going counterclockwise from 0 to the east, you will see that the inner arc shows the 10, 20, 30, 40, 50, 60, 70, 80, then 90 is at the top, then it continues 100, 110, 120, 130, 140, 150, 160, 170, and last, 180 is directly opposite 0, right? Okay, so make sure that you recognize that the right-hand side is going to be 0. Now the little lines in between the degrees, now you see that they're only on the outermost part of the arc. However, they apply all the way to the inner part. So I circled them on the outside. Here it's showing between 130 and 140 degrees on that outer arc. But truly, each one of those little lines can be the subdivision between the 50 and the 40. So since we're using the 50 and the 40, if the line intersects one of those lines on the outer arc, we can assume that it would have also intersected it on the inner arc. We'll look at an example soon where that will illustrate it. And the last thing that you need to identify is the target crosshairs. So if you look where I circled in orange, those are the crosshairs. You're going to line up that hole over the beginning of the line segment that you are planning to look at the angle of. Here's an example. I have it lined up. You can sort of see right where the crosshairs are, the horizontal line, there is a line. It looks like the word school smart is underlined. So that's a line, and then there's another diagonal line going up and to the left, and it looks like it intersects the 130 and the 50. Well, truly, because we defined 0 degrees as to the right and 180 degrees to the left, the angle theta that we are measuring is this angle. It's this obtuse angle from 0 to what looks like either the 50 or the 130, and like I said, because we're using the inner numbers, the true angle theta there is 130 degrees. So again, follow the inside arc numbers. Okay, so here's another example, and as you can see, the protractor is aligned on the grid paper. The line segment goes off up and to the right, and it's between the 50 and 60 degree mark, or the 120 and 130, but as you know already, we are using the lower arc, and so correctly it's going to be some angle between 50 and 60 degrees. However, because we can't see what it is, we have to look at the outer arc, and we can see that there are 10 divisions between, and so that looks like it's at about 126 if you look on the outer rim. 126 means it's 6/10 of the way between 120 and 130, which means if we're going from 50 to 60, because it's going the other direction, it'll be 4/10 away from the 50, so the true angle there should be 54 degrees. If you still have questions, please feel free to email me or come see me, ask me about it in class on Monday. I hope you have a lovely weekend, and I will see you later.